So hello everybody and welcome back to a brand new video, and in this video I'll cover all the problems from round 805 that was a Div3. So let's get started. Also I have around 7 problems today, so I might miss out some things. So if you guys have a doubt, do ask in the comments and I will try to help you out. So let's start with problem A. So in problem A, you have been given some number x, and you have to find the difference from the largest power of 10 that is less than equal to x. So basically you have to find difference that is equal to, or your answer that is equal to x minus largest power of 10 that is less than equal to x, right? So that will be your answer. So it is easy enough. You can just iterate over all powers of 10 until it exceeds x and just find the difference, right? So the answer is just iterate over all powers of x. So go from 1, 10, 10 square, 10 cube, and keep doing so until it is less than equal to x, and your answer will just be x minus the largest power that you find here. So that is right, the largest power that you find. Largest power of 10 less than equal to x. So that will be your answer. So if you want to see the code for this, here is the code. I am just iterating over all powers of 10 from 1 up to 10 the power 10, and if I is less than equal to n, my answer is n minus I. I think that's easy enough. So let's solve problem B now. That is polycarp writes a string from memory. So in this problem, you have been given a string, let's say lollipops. So polycarp can only remember 3 letters in a single day, and you have to write the whole string. So you have to tell the number of days that are required to write the entire string. So for that, you can just start from your first index and start iterating over the string, and try to insert the letters into a set. So I will keep a set that will store the letters. So I will first start from L, then I will insert L, then I go to O, I will insert O, then I try to insert L. There's L already here. Similarly, I try to insert L again, the L is already here, then I try to insert I, then the I is here, then I try to insert P. But as you know, polycarp can only remember 3 letters. So our memory limit is only 3. So if you try to insert P, it will exceed the memory limit of polycarp, right? So if you try to insert a letter and size of set, that is set dot size is greater than 3, then you have to empty your set, right? So then you have to empty your set, and then you can insert P again. So when the size of your set exceeds 3, you will empty the set, and obviously now you have switched to a newer day, so the answer will also increase. So your number of days will also increase, and that is the solution. So if you want to see the code for this, here's the code. So I iterate over the string and I insert it into a set, and whenever the size exceeds 3, I will update my answer, and I will empty the set, and I will insert the new letter. So let's move on to problem C now, that is train and queries. So in problem C, we have been given an array, something like this, where the elements of array are stations. That is, a train starts from station A1, goes to A2, goes to A3, and so on, goes to station AN. Then we have been given some queries of type L, R, and we have to tell if it's possible to start from station L and move to station R. So how can I do this? It's easy enough. We can just keep 2 arrays, left of I, where left of I gives you the leftmost occurrence of station I. Similarly, you can keep a array right, where right of I will give you the rightmost occurrence of station I. And so to answer a query L comma R, you can just check if the leftmost occurrence of station L is less than rightmost occurrence of station R, right? Then you can easily form a path from L to R. Otherwise, the answer is impossible. So that is the solution to the following problem. And if you guys want to see the code for this, here is the code. I just keep two maps, left and right, where left of I stores the leftmost occurrence and right stores the rightmost occurrence. So if my left is not empty, I will update my leftmost occurrence, and I will always update my rightmost occurrence. And so to answer a query L comma R, I will just check if station L is present or not, that is station L exists or not. Similarly, if station R exists or not, and then I will check if left of L is less than right of R, then the answer is yes, otherwise the answer is no. So that was the solution to problem C. So let's solve problem D now. So in problem D, we have been given a string, let's say A, B, B, A. The cost of the string is the sum of alphabet codes. So alphabet code of A is 1, alphabet code of B is 2, B is 2, A is 1. So the cost of the string is equal to 6, right? We have been given some final cost that we want to achieve. So let's call that cost P. So we have been given a cost P that we want to achieve. And to achieve that, we have to remove some letters from the string. So you have to remove some letters from the string such that the final cost is less than equal to P. And to achieve this final cost, you have to remove the minimum number of letters. You have to remove the minimum number of letters. Obviously, if you want to remove the minimum number of letters and make the cost less, the very obvious choice is greedily remove the letters that have the maximum cost. So the solution is greedily remove letters with maximum cost, right? Because you want to make your cost less and you want to do it in minimum number of moves. So it's always helpful to remove the letters that have the maximum cost. So if you guys want to see the code for this, here is the code. So I'm keeping a map that will store the index of every letter, right? So here I'm calculating my the current cost. That is, my current cost is the sum of all letters. So I'm finding it here. And then I start iterating from the letters that are the max cost, because the letters are from A to Z. So the maximum cost can be 26. So I start iterating from Z and I try to remove Z. While the current cost is more than P, I will keep removing the maximum cost letters, right? So I will set the string position equal to question mark. That is, I have removed the letter, and I will remove the cost of that letter. So I will do current minus equal to I, because I'm the current cost of my letter is equal to I, right? So after the cost is less than equal to n, right, I will just print out my string. So for every letter in S, I will check if it's a question mark, that is, I have removed this letter or not. If I have removed this, I will ignore it, otherwise I will print it. So if X is not equal to question mark, that is, it is not removed, I will print it. So that is the solution for problem D. So let's move on to problem E now, that is split into two sets. So in this problem, we have been given some dominoes that are basically pairs. So something like, let's say 1, 2, 2, 3, 3, 4, right? Something like this. And we have to split them into two groups such that no two groups contain a number twice. So let's say I will call this group 1 and group 2. So I insert 1, 2 here. Now I cannot insert 2, 3 here, because if I insert 2, 3 here, it will contain 2 twice, right? So I will have to insert 2, 3 in group 2. Similarly, I cannot insert 3, 4 here, because then it will contain 3 2 times. So I will have to insert 3, 4 in group 1. So given such a set of dominoes, we have to tell if it's possible to split them into two groups or not. So that's the problem. So the very first observation is that a domino cannot contain duplicate numbers. So there cannot be a domino of type x comma x, right? Because it already contains x two times. So wherever you insert it, that set will contain x two times, right? So a domino cannot contain duplicate numbers. And the second observation is I will try to see the dominoes as the edges in a graph, right? So I will make two groups. One group is red and one group is blue. So as you can see, I have three dominoes: 1, 2, 2, 3, and 3, 4. Right. Let's add another domino, that is 4, 1. So as you see here, let's say that I insert 1, 2 in the red group. So if I insert 1, 2 in a red group, I will make nodes 1 and 2, and I will add an edge here, right? Now I will have to insert 2, 3. As 2 already has a red edge, I cannot draw another red edge here. So I will have to draw a blue edge here. So something like this. I will have to draw a blue edge up to node 3. So my 2, 3 has to go in the blue block. Similarly, now 3 already has a blue edge, so 3 cannot have a second blue edge, so it must have a red edge. Similarly, now we have 4. Now 4 cannot have a red edge, so it must have a blue edge. So 3, 4 will go in the red side, and 1, 4 will go on the blue side. So that's how you can segregate it. So as you can see, it kind of reminds you of bipartite matching, right? So the current cycle has even length, so you were able to color. But if you have something like 1, 2, 2, 3, 3, 1, if you try to make this, I will make 1, 2. Obviously, it will have a red edge. Similarly, 2, 3 has to have a blue edge. And now 1, 3 cannot have any edge because 1 already has a red edge, and 3 already has a blue edge. So you cannot add any edge here. So you cannot like insert 1, 3. So the answer in this case is no. So basically you have to add these edges and check if the graph is bipartite or not. So that's basically the gist of the problem. Also, no node can have 3 edges. So if you see, the 2 already has a red edge and a blue edge. So if there is a new domino, let's say 2, 5, right? So now you have to somehow connect 2 and 5, but you have already used red and blue, so you cannot connect 2 and 5. So if a letter has, if a number has 3 edges, then the answer is also impossible. So using this, you made 2 observations. If a number has 3 edges, that is greater than or equal to 3 edges, answer is no. Otherwise, check if graph is bipartite or not. Check if graph is bipartite or not. So that's the whole problem. And if you guys want to see the code for this, here's the code. So I'm basically taking in all the dominoes and making it a graph. That is, if a domino has same number, the answer is false. Also, if some number has more than 2 edges, then the answer is also false. So I'm covering these cases here. And if these cases are not false, then I can just return if the graph is bipartite or not, right? And checking if graph is bipartite or not is a very standard problem. So you can check it out online anywhere, and you can see the code from there. So let's move on to problem F now, that is equate multisets. So in this problem we have been given two multisets A and B, right? So multiset A is something like, let's say 1, A2, so on up to AN. Similarly B1, B2, B3, so on up to Bn. We have been given some operations. In one operation we can choose any element from multiset B, or either multiplied by 2 or divided by 2. So we can choose any element bi from multiset B and multiplied by 2 or divided by 2. So we can do bi is equal to bi by 2, right? And after applying this operation any number of times, we have to tell if it's possible to make multiset A from multiset B. If it's possible to make multiset A from multiset B. So let's see how we can do this. So if you look at the operation bi is equal to bi into 2, you can see that we can apply this operation a number of times, so we can form any number of type bi into 2 to the power p, right? So we can add any number of 2 to the power p factor that we want to. So the main factor is that is not the power of 2. So what I want to say is, for example, if you have a number, let's say ai is equal to 3 into 2 to the power 7, then we have to just find if we are able to form some number bi equal to 3. That is, if we are able to form some number bi equal to 3, then we can just apply this operation 7 times, and then it will easily convert into 3 into 2 to the power 7. So we just need to focus on the odd factors because of powers of 2 we can easily create, right? So what I will do is I will remove all the powers of 2. So if I have something like, so let me take some examples, it will help you understand better. So let's take the first example, that is 2, 4, 5, 24. 2, 4, 5, 24, 1, 4, 6, 11, 1, 4, 6, 11, right? So this is 1 into 2 to the power 1, this is 1 into 2 to the power 2, this is just 5, and this is 12 into 2, 6, 8, how much is this? 2, 12, 2 more 6, 2. So this is just 2 into 3 to the power 3, right? So I will just focus on these odd factors, right? Just keep an eye on these factors, right? 1, 1, 1, 5, and 3. So if I start from 1, right, this is 1, this is 1 into 2 square, this is 3 into 2 to the power 1, this is 11, right? So first of all I will start with 1. There is already a number 1 that is in my array A, so I can just multiply this to the power 1, and now I have a matching factor, so I can remove these. Similarly I check 1, there is already an element that has a 1, right, in my array in my multiset A, so I can just multiply it with the 2 to the power 2, and then I have a matching set. And if I check here, I have a 3 here and I have a 3 here, so I can just multiply this to the power 3, and I will have a matching set in A and B, so I can also remove this. So now we just have 11 left, and if you try to find in multiset A, we don't have any such factor of 11, right? So we cannot apply the first option, that is multiply it with 2. So now we will apply the second operation, that is we will try to divide this by 2. So if you try to divide 11 by 2, right, you will get 5 now. So you know there is a 5 in your array A, so you can match these up and you can remove these. So that is how you can solve this. So let's take some other example where the answer is not possible. So let's say 1, 4, 17 and 4, 5, 31. 1, 4, 17 and 4, 5, 31. So this is how much? This is 1 into 2 to the power 0. This is 1 into 2 square. This is 17. This is 2 square. 1 into 2 square. This is 5 into 2 to the power 0, and this is just 31 into 2 to the power 0, right? So if we try to check 1, there's already a 1 in array A, so we can pair these up. If we try to check 5, there is no 5 in array A, so we will divide 5 by 2, and we will get 5 by 2, that is equal to 2. And there is still no 2 in your array A, so I will divide it again, and it will become 2 by 2, that is equal to 1, right? So first my 5 into 2 to the power 0 became 2 to the power 0, then it became 1 into 2 to the power 0, right? And I have a 1, right? I have a 1 in my array A, so I can pair these up now. So now I have a 31, so let's try to see if I can pair 31 and 17. So I will divide 31 by 2, so it will become 15. I will divide 15 by 2, right? So it will become 7. I will divide 7 by 2, it will become 3. I will divide 3 by 2, it will become 1, and then it will become 0. So we started with 31, then we came to 15, it was also not in array A. We came to 7, it was also not in array A. Then we came to 3, it was also not in array A. We came to 1, it was also not in array A. Then we came to 0, right? So you tried to divide by 2, but you were not able to find the following pair. So if you're not able to find a pair and your number becomes 0, then the answer is impossible. So the answer for this case is no, right? So that is the solution for problem F. So if I want to summarize it once again, the summary is remove all powers of 2 from A and B and try to make pairs. That is, for every element in B, check if BI is present in A. Check if BI is present in A. Otherwise, set BI equal to BI by 2. Otherwise, try to check if BI by 2 exists in, that is, set your BI equal to BI by 2 and do the same thing for BI by 2. And if your BI reaches 0, if your BI is equal to 0, then the answer is no, right? That is, you were not able to find any such pair, then your answer is no. So that is the approach for problem F. And if you guys want to see the code for this, here's my code. So first of all, I remove all the powers of 2 from my multiset A, and I will keep a map to check if my element exists or not. You will see why this is used later. Similarly, I will remove all factors of 2 from my multiset B. Then I will start iterating for all the elements in my multiset B. I will check while my BI is not equal to 0 and I have not found a pair. I will check if such a element exists in my array A. Sorry, in my multiset A, right? Like I'm updating my count here. So I will check if such a element exists in my multiset A. If it does, then I will remove that element. I will form a pair and I will remove its frequency. That is, I will remove its frequency by 1. That is, I have used that element, so it cannot be used anymore. And I will set my found equal to true. Otherwise, I will do BI is equal to BI by 2 and try to find a pair for BI by 2. In the end, if I'm not able to find the answer and my BI becomes 0, then the answer is false, right? If I am able to form all the pairs, I will just return true. So that was the logic for problem F. So let's start with problem G now, that is possible paths. So in problem G, we have been given some sort of tree, right? Something like this, let's say. And then you have been given some queries. In each query, you have been given some set of vertices, and you have to tell if there exists a simple path that contains these vertices. For example, if you have a query of type, let's say 1, 2, and 4, then you can find a path that is this path. This is a simple path that contains 1, 2, and 4. So the answer is yes. Similarly, if the query is 1, 2, and 5, then you can find a simple path, that is this one, 1, 2, 4, 5. It contains 1, 2, and 5, so the answer is yes. It also contains 4, but the path can contain some extra nodes. We don't care about that, but it must contain all the nodes from the query. But if you have query something like 1, 2, 3, 4, and 5, then you cannot form a path. There is no path that contains all these 5 nodes. So given such queries, we have to tell if it's possible, if a simple path is possible or not. So how can we do this? So a simple path is of something type like this, right? A simple path is something like this. How can we find if a node lies on this simple path or not? So let's say my left end, right? This is my left end, this is my right end, and let's say there is some node x. Now I have to find if node x lies on the simple path from left to right or not. So how can I check this? Very simple way to check this is if gap of, that is gap from left to x plus gap from x to right is equal to gap between left and right? That is gap of from x to left and x to right is equal to the gap between left and right. Then obviously x lies on the path, right? So how can you find this gap? How can you find this gap? So if you have left node, you have your right node. Let's say this is your LCA, lowest common ancestor of left and right. So how can you find your gap between left and right? Then it's pretty simple. Gap between left and right will be equal to height of left plus height of right minus 2 times height of LCA. That is how you can find this gap, right? So if you know left and you know right and you know LCA, you can easily find gap between left and right using height of left, right, and height of LCA. So now you know how to find if a node lies on the path, and now you know how to find gap between two nodes. So now the only thing left is to find this simple path. So the only thing left is to find this left, to find this right, and to find this LCA. If we find all these things, then we can simply for every node check if it lies on a simple path or not. How can you find this left and right? So it's easy enough. Your left node will be the deepest node, right? So it will have the highest height. It will have the highest height. So you can just iterate over all the vertices that you have been given the set and find the node that has the maximum height. So to find left, you can say iterate over all nodes in query, and your left will be the node with maximum height. That is how you will find left. And to find right, iterate over all the nodes again, and your right node will be the deepest node for whom the LCA is not left. Sorry, for whom the LCA is not right. So to find the right node, iterate over all nodes, right? Your right will be the node, that is node with maximum height, and LCA is not and LCA of this node with left is not equal to node, right? Because like what I mean by this is let's say your tree is something like this, right? Here is your LCA and here is your left node. if you think about nodes that lie on the path from left to LCA, let's say I check this node that is X. If you try to find their LCA, if you try to find LCA of left and X, it will be X itself. So obviously it is not the node that we are looking for, right? Obviously it is not the right node. If you try to find the LCA of left and right, it will not be equal to right, right? So that's why we are having a condition here. That is, we want to find the node with maximum height such that LC of node comma left is not equal to node. That is, it is not lying on the path from left to LCA. We want to find a node that is not lying on the path from left to LCA. So that's why we have the following condition: LC of node comma left is not equal to node. So that is how we will find left and right. So there might be a case where you are not able to find the right node. So if your graph is something like this, right, it's a straight line starting from left and just ending at the LCA, then you won't be able to find the right node here. But you don't need to find a right node here. Why so? Because the path is a straight line, so all the nodes are already lying on the simple path. So you don't need a right node here. Your answer is just yes, because the graph is the path is already a straight line and all the nodes are already lying on a simple path. So the answer is yes itself. So you don't need to find a right node in this case. So that is the solution to the problem. If I have to summarize it once again, summary: find the left and the right nodes, right? How can you find the left node? Your left node is the node with maximum height among the query nodes. How do you find your right node? Your right node will be the node with maximum height such that LCA of your left comma node is not equal to node. If you are not able to find the right node, then the answer is yes. That is, if can't find the right, the simple path is straight, so the answer is yes. Otherwise, if you are able to find left and right, then for every node in query nodes, check if distance or gap from left comma, let's call this node X, left comma X plus distance of X comma right is equal to distance of left comma right. All the nodes must satisfy the following property. And if all these satisfy the following property, they must lie on a simple path, and the answer is yes. And how do you find this gap or distance? Distance of some node u comma v is equal to height of u plus height of v minus 2 times height of LCA of u comma v. It is also easy enough to see this, right? If you have something like this, here's your LCA, here's your height of u, right? This is h of u, let's say this is h of v. Then your gap between u and v will be h of u plus h of v minus 2 times this height of LCA plus this is height of LCA. So this is 2 times LCA. So you just remove this 2 times and you will be left with height the gap between u and v, right? So that's why we do height of u plus height of v minus 2 times height of LCA uv, right? So that is the solution to problem G. And if you guys want to see the code for this, here is the code. Here is my LCA that will find the LCA for me. NQ, that is my number of nodes, my queries, and the K is the number of nodes in the query. So I will form a graph first, and then I will form the least common ancestors of the graph, right? This is my gap function. It will give me the gap between u and v. So it is just nothing but height of u plus height of v minus 2 times height of LC of u and v. Then I will start iterating over my queries, right? And I will find my left end, my right end. So my left end will be the node with maximum height. So I'm finding it here. Then I try to find the right node. If I'm not able to find the right node, then the path is straight, so the answer is yes. Otherwise, if I'm able to find the right node, then I will iterate over all the points, and I will try to check if distance of left hand comma right hand is equal to distance of left hand comma nodes of I plus right hand comma nodes of I, right? And if there is some node that does not satisfy the following property, then I will set my found equal to false. In the end, if not found, cout is no, otherwise the answer is yes. So these are all the problems from the round, and if you guys have a doubt, do let me know in the comments and I will be happy to help you out. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.